Hey, hi. Hello, everyone. I'm Naval Yamal. Welcome back to my YouTube channel, Data Master. In the previous videos, I have explained you about what is Delta Live Table, and we have seen part 1 of the Delta Live Table UI. And once we run a pipeline, you can see you got a graph that shows you all the 5 tables. Now, in this video, we are going to talk about how the tables are created by using a SQL queries. We're going to see that. Let us jump onto the notebook. Now we look at the SQL query, and we can just jump onto the notebook by clicking on the source code, or you can simply go to your workspace, and from here you can go to your folder and you can click on this. You can navigate to the notebook. So our intention is to understand the syntax, how the tables are created by using a simple SQL query. So to understand this in detail, the prerequisite is you need to know cloud files. You need to know autoloader. So we have explained you in detail about the autoloader. I'll leave you the link for the autoloader. You can check it later on. Knowing autoloader and the structure streaming helps you to clear most of the concepts in this DLT. If you are not aware, maybe I'll take some time and explain a quick note on this. So now we are talking about a DLT framework. I'll just take a note. I'll take a new cell here. I'll try to explain it. So when it's a DLT framework, we will be talking about a data sets. Okay, a data sets of the DLT. I'll just write DLT data sets. So basically we have 3 types of data set. First is your streaming tables. Streaming tables. So this is based on the concept of your streaming data. It is based on the concept of your autoloader. So when it comes to bronze data, we will be using a streaming tables. So we'll ingest the data, and it's not like a streaming what we have seen in the structure streaming or autoloader. It will not stream continuously, but your stream will stop. The stream will stop. So when you run your pipeline second time, so if there is any new data, it will just pick up a new data and it will try to process it. So the concept is same again of the streaming tables, because it depends on the structure streaming. Structure streaming guarantees that you will just read the data only once. Okay, so streaming tables we generally use for the bronze and for the silver. It's not mandatory to use streaming tables, but it is the best practice. And if you ask me like, oh, my data source is not streaming, I just have a batch data, can I still use a streaming? Yes, you can use it, because once the data has been processed, you are not processing that data again and again. You are saving a lot of time for the processing. So we'll focus on the other tables here. So for bronze and the silver, we generally create a streaming tables, and how I'm going to show you now. And the second data set is your live tables. So this is okay, let me tell you. First is a streaming tables, or it is also called as a streaming live table. Now live is just an optional. If you are not writing live, still it works, but you can call it a streaming table, or you can call it a streaming live table. In both the cases it will work. Now second data set is live tables. For the live tables we have the other name, and it's called materialized view. Okay, it's materialized view, and we generally create a materialized view at the gold zone or the gold layer. So now what is materialized view? How it differs from the standard view? So in standard view, whenever we are querying it, it will just go and run your complete query definition. So it's going to run the entire query definition again and again. But when it comes to materialized view, for the first time, it's going to run that query definition entirely, and the results are stored. The results are cached. It will just have a recent snapshot of your data. The second time when you are querying it, it doesn't take a long time to run the entire query definition. It just goes and pick up the data that is already cached. So it will have a recent snapshot of your data sets. So the query time would be really faster when you compare it to the standard view. So if you are creating a reporting or dashboarding on top of this materialized view, the results are really impressive. So you get results way faster than the normal standard view. And you can just create a materialized views by using a delta live table only, because that materialized views are a part of the delta live table datasets. So a quick note, I'll give you a simple analogy. Suppose you have a standard view, and if you're querying it, for example, to query that standard view, it takes 1 minute, for example. Second time, if you're querying it, still it takes 1 minute. Third time, still it takes 1 minute. But if you're creating a materialized view, for the first time, if it takes 1 minute, second time, it's just going to take 4 to 5 seconds. Yes, it's going to cache all your query results, and it's going to just refer that. Unless and until your data is updated, it will cache it quickly. And if your data is updated now, then for the first time, it's going to take a long time to get all that updated data, and later on it will be faster. So for the gold zone, we generally prefer using a materialized views or a live tables. It's called a live tables. When we're writing a syntax, we say create live table, but it's still going to be a materialized view. So knowing these knowledge, let us jump on to the syntax now. So it is very simple. If you know the CTAS statements, CTAS is nothing but create table as select, is a very popular DDL command that helps you create a table from the query. But we are going to do little bit changes here. It's not just a create table, but it's create streaming live table. That's it. We are going to just add a streaming live before that table, and then we are going to provide a table name. So let me write a table name, and then we are going to say as select star from. So if you remember PySpark SQL, where we used to write a file format like a CSV, JSON, and then we provide a path. But here it's a streaming table, it's a streaming. So we'll use a option, we use a autoloader by using this cloud files. So we just mention the cloud files method here, and then we'll specify the path. So path is where do you have the source files. It might be any file format. So yes, your streaming table, your cloud files, autoloader supports all the major formats. It might be CSV, JSON, Parquet, Avro, Delta, ORC, all the file formats it supports. You just provide a path, and then you provide what file format it is, for example CSV, JSON, and so on. So with this simple syntax, you can create a streaming live table. And as a beginner, many people get confused, like, okay, I have a compute, like a all-purpose compute or a SQL warehouse compute. So what I'll do now, I'll just try to use a SQL warehouse compute. Can you see that I have a SQL warehouse compute? It will just take a couple of seconds to start. So I have chosen that. I'll choose this, and I'll try to run this. So many people get confused, like if I try to run this, will I get an error saying that the compute is the table is already created? No, you never get it. But if you're trying to run it, it should throw you an error saying that, hey, this is a table that was created by using a pipeline. So you can just use a delta live table pipeline to run this, and you cannot run it in your normal notebook. So you are writing the code in the notebook, but you are running it in the pipeline. So remember that. So we'll try to run it when we are looking at our own use case. So we are going to take our own use case and try to create a complete end-to-end delta live table. There we are going to use a different computes to run it. Now let us focus on the code again. So we are just saying create streaming table, or you can simply say create live streaming live table name. And these two are just for enriching your table, just to make more meaningful for your tables, like comments and table properties. Actually those are not needed. You will just keep this. We'll focus on the syntax. So create streaming live table name as select star from cloud files. So cloud files is your autoloader. We are specifying a path here. We are specifying the path, and from where this path is coming, this is from the Databricks datasets, as we are using a sample data. But as we progress, we are going to take our own use case where we are going to mount it, or we can use the volumes for that. So this will help you to create a customers table. let me align this to our pipeline. Let me go to the pipeline. Yes, I'm talking about this customers table. By just writing a simple 2 lines of code, a live streaming table is created and it's called a customers. So moving forward now, let me just do the undo here. Let me keep this comment and table properties. These are not mandatory, just to enrich this table. Now this doesn't take much time to move forward to the next bronze table. Now we are focusing on the sales order raw table. You can see here sales order raw table. Again we are writing create streaming live table, and we have just added a comment and table properties. Very simple, these are to enrich your table. And again we are writing as select star from cloud files, so we get all the columns from this data set, but it's through a cloud file. And here we are using a JSON. So this time the sales order is in the JSON format, your customer was in a CSV format, and here we are using a map. So map is just like an option in Python. I mean, when we are writing a PySpark code in autoloader, we use an option cloud files dot format, cloud files dot info column types, and so on, which we have seen it in the autoloader session. So here we are just using that cloud file info column types. So just in case if you have getting a new columns, your schema is drifting, all you can take into consideration by using this map. Rest everything is simple. If you try to run this, you are getting a new table, that is a sales order table. Now let me tell you, we do not have any relation between these two. These two are independent, and we can see that we got two independent tables here. In the graph you can see it, and these two are not depending on each other. Now let me proceed further. We have the third table. Let me switch back. You can see this is the third table. Now this is interesting. Now this sales order clean table, you can look at the image and you can figure out that it was created by using these two tables. We're going to see how it was created. Let us go back. First thing, create streaming table, table name. Then we have set up some expectations. So we'll skip this expectation. We'll skip the partition by comment and table properties for a few minutes. I'll just skip this. Now we'll focus on the SQL query here, what exactly we have done here. So we are selecting few columns. So again, it's column from both the tables. We are doing some type casting here. We are changing that to a Unix timestamp from the, we are converting it to the timestamp, so on. Okay. We can build the logic here. We have selecting few columns from both the tables. But the interesting thing is, select the columns from table. So we generally say select columns from table. You do a join, then mention the right table. In left table, join right table. We mention the join type. In this case, it's a left join. But now you look at the detailing here. We have mentioned something called live dot. So this live is nothing but it acts like a schema name. It's not a database actually. We do not have any database called live. It acts like a namespace that helps you to build a dependency. So this is so powerful by just mentioning live dot order sales raw. Okay, order sales raw is here. Okay, so we are taking this table and then we are joining it to live dot customers. Oh, customers table is here. Can you see that? So this live will help you to make a dependency. And here, because of this live, these two were depending. I mean, the silver table is depending on these bronze tables. Now, you can see here, this silver table is a streaming table. Again, we are just writing create streaming live table. If this is a stream table, we need to enclose this table with a function called stream. So with this function, you are sure that your silver table is a streaming table. So we have to enclose this. If you are not taking this as a stream, you don't need to put this stream function here. Okay, so try to remember, if it's a streaming table, you have to enclose that to a stream, because we are referring it to the one of the table in the pipeline. So we have to enclose them to a stream. So let me do a quick undo here, and now understanding these concepts, simple. Every table we mention it, the delta live table, the dependencies should be used this keyword called live. Okay. Now after this, we will focus on the constraint part. So this is again a very interesting thing. So this will help you to achieve your data qualities. You can use the constraint, and you can use three types of actions here. This will really help you to achieve any data quality checks. It's so amazing and it's so simple to understand. So it starts with constraint. Constraint, you add a constraint name. We are expecting that order number is not null. So in my table, my order number should not be null. Just in case if the order number is null, I mean it violates, right? It will start violating it. So that records get violated. If it violates, you drop the row. You drop the row. So you can figure out if it violated. You can check them in the streaming silver table in the data quality. You will figure out how many records got dropped. You can see here in the expectation. It is so powerful by just adding a constraint. And repeat now, constraint name, expect the order number is not null. On violation, you drop a row. You drop a row. What all actions you can take? The first is you can take a warn action. Warning means it will just show you the warning, but the records are written to the target table and it will say that okay, these many records got violated. Second one is drop row, means it will just drop the row. It will not write it to the target table. Very useful if you're dealing with a primary key where you don't want any duplicates or null values in your target. We can do this constraint. And the third type of action you can take is a fail. So if there is any corrupt record, if there is any bad record coming in, just you fail the pipeline. You stop this entire process. You can do that also. Depending on the use case, you can. So that is about the silver table. Okay, so we have a constraint. Then we are violating. I mean, on violation, we have three actions as I told you: warn, drop, and we have a fail option. You can check in the internet. We have a document. I'll give you the document. Check how the syntax looks like. Now we have just partition by. So you know what happens to the partition by. Behind the scene, you are just creating a folders, and we are just saving the data in a Parquet files in that particular folder. Just to when you are querying it in the downstream, else would be really fast. It will just scan those particular folders, not all the folders. Okay, so this is about the silver table. Now moving further, I'll be talking about materialized view. Now materialized views are nothing but full table, and here the challenge is again how the dependencies, how these dependencies was created. We're going to focus on that, and we got only 99 records here. So maybe we have done some grouping based on the city called Chicago or where the city equal to LA. We're going to see that, and then we're going to see how the dependency is created and how the materialized view was created. Very simple. Let me jump on. So both the syntaxes are same, just we are going to filter it by Los Angeles here and then by the city called Chicago. Rest everything is same. Here, let me focus on the first line. It says create live table. Now it's not a streaming table, it's just a live table. So when you say create live table, it's just your materialized view, nothing else. We're just talking about a materialized view. And then we have comment and table properties, enrich a table. So let me explain you the inner query. So we have selected few columns, we have exploded it. So we might have an array, we have exploded that array from live dot. Cool, can you see that? So we are referring a silver table now. Silver table is here. From this silver table, we are using a namespace called live that will help you to create a dependency where the city equal to Los Angeles, and we are taking this results, we are passing it to the outer query. You can check that we are grouping it by these all columns. Very simple. Grouping it, doing some aggregations, some count, and so on. So this will help you to create a materialized view, and the dependency will be from the silver table, and we are grouping it and aggregating. Similarly, we can do for the city called Chicago. Everything is same. So with this 5 lines of code, we were able to achieve a complete end-to-end ETL, creating a pipeline, monitoring a pipeline, and we have also seen a data quality checks and improve the data quality by adding these constraints, setting up some expectations, and also we were able to achieve the medallion architecture, moving from bronze to silver, silver to gold, and also the dependencies are automatically created. We are not worrying about it. Now let me take a moment here. Let me explain. Suppose you want to take this pipeline and you want to add it to a different task, like, oh, this is my ingestion task, or after this I want to do a querying, I want to do a machine learning, and I want to schedule it. Can I do that? Yes, the beautiful feature is in the jobs. You can just go to the workflow jobs, hit on the jobs, and here you get an option. Choose a type, like you mention a task name, and you can choose a type as DLT. Cool. Can you see that? You can just choose it as a DLT, and just you can mention your pipeline name. In my case, I have a couple of pipelines. Let me do this, and then you can start scheduling this, starts triggering this, and even you can go beyond this and you can create couple of tasks also. For example, DLT, let this, and here you can take a different task. After you create all the tables, I want to query this, I want to do some machine learning, or even I can run a different jobs after this. So maybe we are going to do this with our own examples, but for now I've tried to explain all the syntaxes of the SQL for the DLT, and we created a complete pipeline from using sample. So that's all for this video, guys. Thank you for watching. Like the video, we have done three different videos here. First one was DLT, second was UI part, and was on the SQL code on the DLT. Now we are going to take our own example and then we are going to build a complete end-to-end caption project on the DLT. Thank you for watching. I request you and share it with your. Thank you. Bye bye.